Hi everybody, welcome to another video in Trigonometry, section 2.3, more application of right triangle. Right, first we define bearings. So a bearing is the measure of an acute angle from the north or the south line. So let's look at this. This line, the bearing of that line is 40 degrees from the north. Of course, this is north, east, south, and west. So in this case, 40 degrees here, the bearing of that is, we start from north, we go 40 degrees on the east side. So that is the bearing of that line. Next, the bearing has to be with respect to the north-south line. So I have to find this angle. 90 degrees in total minus 40, so that's 50 degrees. So the bearing of this one is start from north, go 50 degrees on the west side. Right, so the bearing is with the north or the south line. So we can also have, with respect to this south, that's 65 degrees. So we start from south, or 65 degrees from west, on the west side. Of course, there are different ways to write the direction too, but this is one way to write the bearing. And also, this is south 30 degrees on the east side. Right, so easy enough. Now, here's some example. A camper leaves camp and hike 2 miles due east, and then turn and hike 5 miles due south from the camp. What is the bearing of her new location? So let's just write in general. This is where the camper start the hiking. 2 miles due east is on the right. Say 2 miles. Yeah, just say this much. 2 miles. Right, about 2 centimeters. 2 miles due east. And after that, turn and hike 5 miles due south. 5 miles will be way in here. So let's say this is 5 miles. Not exactly, but you get the idea. So 5 miles due south from the camp. What is the bearing of her new location? So because she go east and then south, so we'll make a right triangle here. And because the right angle is here. So we can find this angle or that angle. It doesn't matter. Just pick one. Right. I will try to find this angle here. And let's say this is angle A. Now with respect to angle A, 5 miles is opposite to angle A. And 2 miles is adjacent to angle A. So opposite, adjacent, that tangent. So tangent angle A is opposite over adjacent. So angle A will be inverse of that ratio. So once again, make sure it's in the degree mode, the right mode, before we do the calculation. So tangent inverse of 5 divided by 2. So 68.198. Keep 1 decimal places then. By the way, if we want to hit second apps, and we can go to degree minute second, so we can write like that too, but I'm not doing that. I just say 68.2 degrees. Alright, but the question is, as for the bearing though, so the bearing is have to be with respect to the north or the south line. So in this is not the angle we want. The angle that we want is this angle here. So that is the angle that we want. So we have to subtract from 90. So if you use 90 degree, I'm not going to type 68.2. I'm going up, highlight that number, hit enter. If you cannot do that, type the whole thing. So that is 21. Yeah, in here I can just write like this. But the actual numbers I'm going to use is on the calculator. 21.8014 something degree. Right. Let's just round that to 1 decimal places. 21.8 degrees. So the bearing is 21 with respect to the south on the east side. So this is the bearing of the new location. Right. That's simple enough. Next, let's look at this example. The bearing from a disabled ship to a rescue disabled ship is able ship, and the rescue vessel is R. So the bearing from the disabled ship to a rescue vessel 59 degrees south on the east side, so that's 59 degrees. The bearing to the nearest port from the disabled ship 57 degrees north, 57 degrees east. So this is from the disabled ship to the port. Is that the bearing from the port to the rescue vessel is 31 degrees south, south 31 degrees west. So from the port to a rescue vessel, assume that the rescue vessel is 56 miles away from the port. That's what we have. All right. Now there's look like something missing here, right? So what's the missing? Let's look at the title. Application of right triangles. So where's the right angle? It says, yeah, that look like the right angle here, right? But we cannot say that. We have to prove that it's actually a right angle, so we can use trigonometry of the right triangle. So how do we do that? So first of all, the angle D, the whole thing is 180, right? It's for the north-south. From north to south is 180 degrees. So first we can calculate this angle here. I take 180, subtract those two angles. Minus 59, minus 57, 64 degrees. Right, what else can we do? Somehow we have to show that this angle R is 90 degrees. How do we do that? Now, it will be a bit grounded, but I will try to draw it again here. Right. Now, we have 64 and 59, so if we talk about the whole angle here, (64 plus 59), that is 123 degrees. This is 31. Now, note that the angle D and this angle here, 123, and that angle have to add up to 180 degrees because they are interior, same side interior angles add up to 180 degrees. Right? So, this back in section 2.1 or 2.2, 2.1, if we have two parallel lines and a transversal, these two angles are equal because they are called alternate interior angles. These two angles are supplement because they are called same side interior angles. So pretty much in we have two parallel lines, a transversal. If the angles, both of them acute or both of them obtuse, they're equal. If one of them acute and one of them obtuse, they will be supplement. So 123 and the whole angle there are supplement. So let's see, what we're trying to find is this angle here. Which is, let's say, x. So 123 degree plus x plus 31 have to be equal to 180 degrees because same side interior angles have to add up to 180 degrees. So 123 plus 31, 154 degrees. So x is equal to 180 minus 154, 26 degrees. Now we know 26 degrees there, 64 degrees here. 26 plus 64 is 90 degrees. So in this triangle, all angles add up to 180 degrees. So angle D, R, and P add up to 180 degrees. Two of them is 90, meaning the remaining will be 90 degrees. So in this we have a right triangle. We can use the trig function, right? So assume that the rescue vessel is 56 miles from the port. Find the distance between the rescue vessel to the disabled ship. So we ask to find this length here. Let's draw that triangle again. This is actually the right angle here. Right, we're trying to find here. Right, now we have a few options. We can use 26 and 64 degrees. By the way, in this problem, all of the angles, all of the information are calculated. So I have no choice of using the original numbers. Alright, so let's use 64 degrees then. Alright, 64 degree. With respect to that 64 degree, 56 degree is, yeah, I'm sorry, I did not write the right triangle properly. Yeah, this is not quite a right angle. This is much better. Right. So this is opposite to 64 degrees. So this is opposite, and x is adjacent. Yeah. So this is much better. Just look at this. 64 degree, 56 is opposite. This side we're trying to find is adjacent. Again, the ratio that have opposite and adjacent is tangent. 64 degree opposite over adjacent. Tangent 64 degree opposite over adjacent. Cross multiply x tangent of 64 degree equal to 56. So for x, divide by tangent of 64 degrees on both sides. (56) divided by tangent of 64 degrees is 27.31. The unit look like small. So that look reasonable. This will be smaller than 56 because opposite to the smaller angle will be the shorter side. 26 degree opposite to that supposed to be shorter than opposite to 64 degrees. In this case we have 27.31. That look reasonable. Right. So that. Next we have more application of right triangle. Right. Now, this is an interesting example. Arranger find out the angle of elevation from his current location to the top of the tower is 28.3 degrees. After walking 50 feet toward the tower, he finds that the angle of elevation to the top of the tower now is 31.2 degrees. How far is the ranger from the tower originally? So this application is extremely important. So I'll give you an example. Let's say we're trying to find the height of the tower, or the height of a mountain, the height of a tree. And we stand here looking at it. If we can walk all the way to the base of the tower, if we can walk down here, we just need one triangle. That easy, right? If we can walk from the location, if we know this side and with the angle of elevation, we can find the height of the tower easily. The problem is we don't know where the base of the tower is. That's first, but more important, let's say there's the fence right here. We cannot walk through the fence to the base of the tower to measure that distance. So that is impossible. So the way we do that is we either step forward or step back. If we take the step forward or step back, and from here we measure another angle of elevation. Knowing these two angle of elevation, and the distance between here, we can find the height of the tower. So this is extremely useful. So next time when you go camping or hiking, there's a leg and there's a tree on the opposite side of it. You stand here and try to find the height of the tree. Just find two distance. Either we step back or step in either direction. And we know this distance, we know the two different angle elevation, we can find the height without actually go to the base of the tree or the base of the tower. So that example, this example is extremely important. So how do we do this? Right, the topic for this is called the related triangles, meaning that we have more than one triangle, more than one right triangles. Right, so we know only 50 feet is only measure length here. So how do we find it? So remember there are two right triangles, right? I'm going to write two of them. I'm going to draw two of them. First, not up to scale because I wrote exactly, that would be difficult to calculate. So we'll draw the right triangle here. The tower is still the same height though. This is the height of the tower. First, the one smaller one is 31.2 degrees. Now draw the skinnier. uh, 28.3 degrees. So those are the two right triangles. What we're trying to find is how far the range of, how far is the range of from the tower originally. So we've asked to find this distance originally. He walking toward the tower, so originally this is the distance that we need to find, meaning this is x distance. Right, since he walked 50 feet toward the tower, this distance here is x minus 50 . So for two right triangles, we have this information, right? And the question here is, did not ask for the height of the tower, but if we call that h, or the height of the tower, right? So those are the two triangles that we have. We have x and x minus 50, right? Now let's set up the ratio. With respect to 31.2 degrees, we have h, the opposite, and x minus 50 is the adjacent. H opposite, x is the adjacent. Now with respect to this right triangle, sine of 31.2 degrees equal to opposite, which is h, over adjacent. Right. For the other triangle, sine of 28.3 degrees, opposite h over adjacent x. Now, two variables h and x, two equations, so that should be able to do it. Now, let's just cross multiply. We have h equal to x minus 50 times sine of 31.2 degrees. and then we have h times 1, h equal to x times sine of 28.3 degree. Right, does that help? Definitely, because both of them equal to h. Since both of them equal to h, why don't we make them equal each other? So x minus 50 sine of 31.2 degree equal to x sine of 28.3 degree right, multiply them out. X sine of 31.2 degree minus 50 sine of 31.2 degree equal to x sine of 28.3 degree. Right. X times sine 31.2 minus 50, so we just multiply it out. By the way, sine of 31.2 degree just a number, so instead of writing some number, I just keep sine of 31.2 degrees. Right, multiply them out. Now we solve for x. So subtract this to the other side, and we're going to add to the other side. So move on the x on one side. X times sine of 31.2 degree. Move this to the other side, that becomes subtract x minus x times sine of 28.3 degree. Move this to the other side, 50 sine of 31.2 degree. Factor out the x. So kind of small. Right. And then we just divide that to this. Notice that here I do not do any calculation here and get any nice number. Just put all the calculation at the end, and that ideally the way we want to do it. So (50 sine of 31.2 divided by sine of 31.2 minus sine of 28.3. That is 589. That would be fit. Right. So again, alpha y equal to give us a fraction, and we can type exactly as we see it. Or if we cannot do that, we just say 50 sine of 31.2 divide by sine of 31.2 minus sine of 28.3. Close. Yeah. Wait. Let me type again. 50 sine of 31.2 divide. We have to put the parentheses for the denominator. Sine of 31.2. Subtract sine of 28.3. Close. Yeah, so that's what we have. Right. So, like I said, this example is extremely handy in the situation where we cannot actually physically walk to the base of an object to measure the height. So in that case, we can still find the height of an object looking from a distance. Right. Here is another example. From a tower that is 150 feet height. So the height of a tower is 150 feet. And 50 feet high. Look it up, by the way, with the sun directly overhead. So if the sun is on the top, it will project everything down. An airplane and a shadow. So here an airplane, and the shadow of the airplane will be directly down because the sun is overhead. The airplane and the shadow will be perfectly perpendicular to the ground. And this is the top of the tower. So we say tower. And we have 67.4 and 8.1. By the way, these two add up do not equal to 90 degrees. So this is not a 90 degrees angle. Right. The question is, how height is the airplane, for the height of the airplane. So we're asking to find the big distance. So what we see here is that these are two right triangles. Here. Two right triangles. So opposite to 67.4 is that height and this height. So this question is we're asking for the height of the airplane. So the height of the airplane, yeah, how do we find that? In this triangle AT, let's this called H. In this triangle TA and H, we do not know any side, so it's not going to work, right? In the right triangle, in order to solve it, we have to know one side. Knowing only angle doesn't help at all. We have to know at least one side, so that doesn't help. For the triangle TH and S, we know a side 150 feet. So we can find everything about the triangle TH and S. Right? So first, let's draw the triangle TH and X. THS. $150 feet. Right, now certainly we have an angle, we have the side, and we have the right angle here. So definitely we can find anything about this right triangle. But what do we actually want in this triangle? Well, the thing that we want in this triangle is the common side between the two triangles. So we need to find TH. Because one we have TH, TH is also the side of the other triangle. So we can go from this triangle to the other triangle. Both of them share the TH. So if we can find TH, we know everything about that triangle. Right, so for this triangle, we will find TH. So with respect to 8.1 degrees, this is opposite. With respect to 8.1 degree, this is adjacent. And with respect to 8.1 degrees, 150 is opposite. So tangent of 8.1 degree opposite over adjacent. So tangent of 81 degree, 8.1 degree, sorry, tangent of 8.1 degree equal to opposite is what, 50? Over adjacent we don't know, but it is TH. Cross multiply TH, tangent of 8.1 degree equal to 150. So TH is equal to 150 divided by tangent of 8.1 degree. Right. So 150 right, look like the calculator is frozen, so let me restart it. Just the calculator, I hope, not the video. Right. One still in degree mode, so it's good. 150 divided by tangent of 8.1 degrees. 1053 feet, 0.95. Of course, we're going to use the whole number. We're not rounding anything at the very end. Right, so we have that, which is good, TH. Now we go to the other triangle, TANH. So there's 67.4 degrees. What do we find in this triangle though? Since we find the height of the airplane, we need to know AH. So we're looking for AH. And we know TH. We know TH. Now with respect to the angle 67.4, tangent of 67.4 equal to opposite, which we don't know, which is AH, over the adjacent, which is TH. We do know that. Cross multiply TH, tangent of 67.4 degree equal to AH. We're looking for AH. So AH equal to tangent TH, which is this. Time tangent of 67.4 degree. Right. So once again, I'm not going to round this number. I'm use the whole number times tangent of 67.4. Yeah, it's still in degree mode. So that is 2531. 0.96 feet. And finally, the question is find the height of the airplane. Note that the height of the airplane is AH plus HS. So we just add 150 to this. 150 hx. And we have 2681.9, let's say 2682, let's say, round to the nearest fit. Right, so that is the height of the airplane. Yeah, so that's the reason we call this is related triangle. So we have two triangles attached to each other. We can find a common height. By the way, we can do the same thing here. We don't even need to find th. We're trying to put both of them together. But sometimes just write out the number so we have easy to see the relation between them. But these are the examples I want to do in this section. As always, thank you for watching and see you in another video in trigonometry.